Today we will be learning about rational inequalities, and our learning goal right here is to be able to solve rational inequalities using a variety of methods. And for our success criteria to solve this, first we would have to move everything over to one side of the equation, and then second we would find the LCM and factor the equation. After we find the lowest common denominator, we'll determine the asymptotes or the x-intercepts on a number line or a chart. In our presentation, we're going to do both to show you exactly how to do it. For the fourth point, we're going to use the test points to find the positive and negative places between intervals. And for the last thing, we're going to choose which intervals fit the inequality. The inequality that we're going to do is this inequality: 20t over t plus 1 is greater than 240 t plus 8. So what we'll do, we'll factor it, because the like terms 20t and 240 you can divide it, so 20 into 240 goes 12 times, right? So there's t left over from the 20t and 12 from the 240, and we put that as greater than, we bring everything over to one side as we stated in the first criteria. So we bring it over so everything is greater than 0. For our next step, we then expand the equation which we have and cross multiply. So we have from here to here, we'll cross multiply t times t plus 8 and t plus 1 times 12, negative 12. So this is what we have here. When we expand it and we solve it, we have t squared plus 8t minus 12t minus 12, which is all greater than 0. So what we do after this, we factor these t12 equation, and we have t2 minus 4t minus 12, which is greater than 0. So when we factor this down here now, we have t minus 6, t plus 2 over t plus 1 over t plus 8, which is greater than 0. So one thing that we should note is that all our vertical asymptotes are denominators. So in this case, it would be negative 1 from the plus 1 here, negative 8 from plus 8 here. Our x-intercepts would be negative 2 from above here, and plus 6 right here. Okay, pause it. To determine the asymptotes or x-intercepts, we also use a number line to show you graphically. So, we know that our vertical asymptotes in this case were negative 1 and 8 from the previous clip, and we know that the x-intercepts were negative 2 and positive 6. So what we do to test this out, we use test points to see that which one are greater than negative 8 and less than negative 8. So our less than negative 8 would be the negative 9 on the number line, and which is greater than negative 8 would be negative 4. So we test the points to show us a point that's closer to these two right here of the vertical asymptotes. And for our negative 1, we use a similar point. We use negative 1.5 and negative, and 4. So this is greater than negative 1, and this is less than negative 1. Okay, these are our test points, by the way. What we did for the number line chart was that we plugged in the values for t minus 6. So we did a value that was, that was less than negative 8 when t is less than negative 8. So my value is negative 9. So all you do is plug the negative 9 here into the t minus 6. So it's going to be negative 9 minus 6, which gives us negative 15. Thus, the whole equation overall is going to be a negative. So, and for the next equation we did was when t is greater than negative 8 but less than negative 2. So I plugged in negative 4. So this whole equation would be negative 4 minus 6 would be equal to negative 10. So thus a negative sign right here. And for this equation over here, t is greater than negative 6. I did t equals 9 because 9 is greater than 6. So when you plug in the equation again, it's going to be 9 minus 6, which is going to be 3. So it's positive overall. So after this, I printed all this chart, and since our whole equation or whole inequality was to see like if t over t plus 1 minus 12 over t plus 8 is greater than 0. So we find all the equations that are overall positive, so we will highlight them. Basically, a note is that if there are odd numbers of negatives, like here, like 1, 2, 3, the overall thing is going to be negative right here. And if it's a positive amount of negatives, like over here, seeing there's 1, 2, 3, 4, the overall equation will be positive, such as like a negative times negative gives you a positive. Okay, so for our whole equation, we're taking all the positive ones, which are right here. So I'm going to highlight them right here. And then this one. This one over here. So basically, these are the equations that we would use. T greater than 6, negative 2, T greater than negative 2 but less than negative 1, and T less than negative 8. These are our positive inequalities.